topic for today's presentation is OR tools. What is OR? OR tools are optimization research tools. They have, so the Google have created this using C++, and this is the software suite which you can use to solve the problems, such as linear optimization, constraint optimization, and all those things. So, and this you can install in your PC or anywhere, and you can start using that. So the code is given in the C++ Python, and they have their own directories and functions. So let's start with what is optimization. So does anyone know here what is optimization? Without looking at the slide. So see, optimization is everywhere. Like just now, Professor mentioned, like we need to do everything within the given limited time period, and we want to find a proper solution out of that. So the definition of it is like to find the best solution to the problem out of large set of possible solutions. So like we have, whenever you're coming back from a college or office, you always take a route, like a shortcut, where you can avoid all the traffic and everything. So that is the optimization in day-to-day life. How it is there in the data science? So in data science, what we do is we create a model, and what we want is that model should have a minimum functional losses, and it should give you the proper solution for that. And so there you can use the optimization frameworks. So starting with the linear optimization. So linear optimization is a method of computing best solution to the problem out of other set of out of other problems. So let's say like you can take this example here. What he is doing, let's say FedEx delivery man have to deliver some stuff to all these 6 places, and they have given the distance, route, and everything. So you can create a linear equations with all the constraints that they have given there, and you can, how you solve the linear equation, you can find a solution to these kind of problems. So moving ahead, we will take one example of a string similar that. So this concept was coined in some 19th century, and they wanted to get a solution in terms of the linear equation, and they wanted to find it. So what was the problem here was, this is the nutritional diet which you should have, and all this it should have everything of this nutrition like iron, calcium, and everything, but it is not given in terms of a unit, it is given in terms of a dollars. So here it's like, if you want to spend like a minimum number of dollars with covering all the nutrition, you have to take every constraint in the consideration. So, and they tried to solve this thing using the linear equation and everything, and it took them for like around 120 days. But if you take OR tools, they have provided some amazing functions and wrappers. So they have their own code and the wrapper. So what it does is, it can find, yeah. Sorry. So they have given their own functions and open source system, so you can use that. So here you can say they have given a wrapper that is made by WRPP, so you can use that wrapper, and you can create a data and then form variables and then form equations using, so that you can see here that they have used different functions, and then you can solve this equation within like 300 milliseconds. So you can see here that how using OR tools you can solve big problems within like few milliseconds. Other than that, they have given one add-on feature. So like you can install this add-on onto your Google Drive, and if you want to solve any linear equations, you can do that. So this is just the one example where there is a chocolate manufacturing company, and they want to maximize their output, which is like they want to maximize the profit of the milk and chocolate which they manufacture. So this is some equation, and I can show that how you can add. then I can just set up the optimization sheet, and I can add different features so that I can add variables, I can add constraint, and same way I can just click on solve and solve any kind of linear equation on my images. So yeah. So moving ahead, Priya will complete.
Thank you, Rajashri, for explaining us about linear optimization. I'm Krina Thakkar and I'll be forwarding the presentation with constraint optimization. So constraint optimization is based on feasibility rather than optimization. Our main focus will be on constraints and variables rather than the objective function. So what is a feasible solution? So it is basically a set of values for the decision variables that satisfies all the constraints in an optimization problem. Let's take a look at a simple example and consider employees employee scheduling problem. So there are 4 employees and there are 3 shifts to be assigned, 8 hours each. So the manager has to assign 4 of its employees to the 3 shifts by the end, like the fourth manager has to assign 4 of its employees on the 3 shifts, and the third employee should be given a day off. So per day, how many possible ways are there for a manager to assign employees?
I can answer.
Yeah, 4 factorial. So which is 24 possible solutions. So a manager has 24 different ways to assign a employee for the particular shift. So for a particular, so in a week, there can be 24 raised to 7 different possible ways. So which is around 4 million. So this is a huge solution set which we will optimize using by adding a constraint. So our main aim for the constraint programming is we will narrow down a very large set of possible solutions to a more manageable subset by adding constraints to our optimization problem. So here we can add constraint like each employee can have some minimum number of hours per week to work, or no employee can work in a consecutive shifts. Google OR tool provides us 2 solvers for constraint programming. One is CP set solver and the other is original CP solver. It is more preferable to use CP set solver because it is more technologically superior than original CP solver. But for a smaller data set, it is original CP solver outperforms CP set solver. So let's retrace our original problem and consider it using a CP set problem. So there are 4 employees and a manager has to assign these employees for a 3-day period. So let's add the following constraint. Each day has 3 shifts of 8 hours per 8 hours, and each employee is assigned at least 2 shifts during the 3-day period. And every day, each shift has a single employee, and no employee can work more than 1 shift per day. These are the 3 days and the possible shifts the manager can assign to the employees. Another interesting problem we can solve using constraint program is cryptarithmetic puzzle. A cryptarithmetic puzzle is a mathematical exercise wherein the digits of numbers can be represented as by letters. So there can be multiple solutions for this exercise. Say CP is 1 equal to true. So here C is 2 and P is 3. So we have to satisfy this mathematical equation and assign digits to each of these letters. So there can be a huge solution set for this. So we can add constraints like 10 letters, all the 10 letters must have a unique digit. And the leading digits like C, I, F and T cannot have a 0. Because in a number does not start with a 0. another problem is n queens problem. So the problem says how can n queens be placed on n cross n chessboard so that no two of them attack each other. So let's try few of the iteration for an n queens problem. Let's say we have 4 by 4 chessboard, and if we place, let's start with the leftmost column and place the first queen in the corner. So if q1 is here, our constraint is no queen can be in the same row, column, or the same diagonal. So we cannot place any of the queens here, here, or either here. So the available positions are this. So let's place a queen over here. So if we place a queen over here, we cannot place it over this column, this row, this diagonal, and this diagonal. So we can see the third column does not allow us to put up any queen, and only fourth column is left where we cannot put our 4 queens. So let's try other iteration. So going back to the initial stage over here is called backtracking. Now let's put our queen in the second row of the first column. So the possible ways are, we cannot put it here, not here. So then keep this queen here. Cannot put this over the same column, same row, same diagonal. So we can take this queen over here, and not this row, not this column, and the left one is this. So here no two queens attack each other, and our problem can be solved this way. So we can see the running implementation of the n queens problem. This one is for 8 by 8 chessboard, and there are 8 queens to be placed. So x0 indicates the first column, and the 0 indicates the row number. This x1 indicates the first, second column, and the row number. 6 is the row number. So let's try for the 4 by 4 matrix. So we have two possible solutions for the problem we just saw. So here x0, which is the first column, and the 2 is the second row, x1 is the second column, and 0 is the first position. 0 is the row number indicates, x2 is the third column, and the 3 indicates the row number. So Hardik will be moving forward with the presentation.
Good morning, everyone. My name is Hardik Soni, and I'll be talking about integer optimization today. So, Google OR Tools has provided a lot of solvers. So, the first one being the linear optimization, which Yashasvi spoke about. The second one being the constraint optimization, and the third one being the integer optimization. And then there are additional routing libraries which OR Tools provides. So, talking about integer optimization, you have a problem. So, a problem that will always have constraints and variables as integers. So consider a simple example that a company wants to manufacture certain consumer items, and those consumer items or manufacture certain consumer items which can only be which can lead you to maximizing the profits. So the items that can be produced will always be produced as integers, as the whole numbers, and it cannot be a continuous value. Like you cannot produce something which is part or half. So that is not what the integer optimization will solve a kind of problem. The second example would be if the company wants to expand their business. If they were planning to open 2 new departments in a different city, and they wanted to have a warehouse in one of these cities, the optimization will always look at variables which are either I should build warehouse in this particular city, or either I should build the warehouse in that city. So it's always either 0 or 1, which is Boolean variable. So integer optimization basically looks at solving problems where the integers and where the variables and constraints are integers. So I'll give you a brief background about what variables and what constraints are. But Google OR Tools provides two types of solvers for integer programming problems. The first being the mixed integer programming problem, and the second being the constraint optimization, which Krina just explained about. So mixed integer programming is basically, as the name suggests, the variables and the constraints that you have could either be pure integers, or they could either be like some of them could be continuous values, or combination of integers and continuous values. So let's take an example here. Suppose a company, a chair and a table manufacturing company, they want to produce chairs and tables out of 21 square meter of wood, and each chair would actually consume 6 square meters of wood, and the table would consume 7 square meters of wood. So those are my variables when I talk about it in the formulation form, and when I have to use that formulations in the Python solver that Google OR Tools provides. So those are my variables. And then talking about, so those are my constraints actually. When I say 6 square meter of wood and 7 square meter of wood. What variables do I have here is each chair that is sold at $12, and table is sold at $13. So those are my variables. And my problem here is I want to find out how much maximum quantity of chairs and tables could be produced utilizing the amount of wood that I have. So it could either be like 3 chairs, 1 table, 2 chairs, 1 table, something like that. So taking the similar example back in the how you could use the solver to solve this problem is, you would basically have to define the problem, as in formulate the problem. So you what you see here is 12c plus 13, sorry, yeah, 12c plus 13t. 12c is basically cost of 1 chair, and 13 is cost of 1 table. And when I put the quantities, I would basically come to know how much profit or revenue I'll make after putting in all the constraints and variables in the code here. So what you do here is you just basically define your, define your formulations, and once you define the formulations, you then identify your constraints. So for this particular example, my constraints are that each chair would consume 6 square meters of wood, and each table would consume 7 square meters of wood. And the total amount of wood that I have is should be less than or equal to 21. So that's one of my constraints, and the chair and table could always be integers. That was the another constraint that I had in. So this is just a high level overview of how you can use a solver using Python. So you just have to declare the solver. So there are multiple solvers available, as in one being for linear optimization, one being for integer, and one for constraint. So you have to use like the integer programming solver, mixed integer programming solver, and when you're once you're done declaring the solver, you have to declare the variables. So what I'm doing here is I'm declaring the variables c and t for chair and table, and then I'm defining my constraints here. So I'm defining the constants that I have in the set coefficient method, which says that 6 is the constraint for chair and 7 is the constraint for table. And then you have your objective, as in I want to maximize, meaning I want to understand how much profit I will generate from 21 square meter of wood by selling each chair at $12 and table at $13. So this is my problem statement which I want to maximize. I'll just go through a quick. Yeah. So what you see here is the number of variables that I had was 2. The number of constraints that I put in was 1. The 6c plus 7t was one of my constraints. And what is the optimal objective value? So how can I maximize the profit out of the constraints that I had is 39 rupees. And yeah, and how much should I produce? So it's basically 0 chairs and 3 tables. So you could add in multiple constraints. You could add constraints like there has to be 1 chair produced, or there has to be anything, any constraints that you want to put, you can add in those constraints as well. So this was one of the solvers that Google provides for integer programming problems. The second one being the CP approach that we have, which Krina just spoke about. So the difference between the CP approach and the integer optimization approach is when you know that all your variables and all your constraints that you have, all the variables that you have need to follow a specific set of constraints, then you have to use integer optimizations. And when you have to identify a particular solution out of a set of solutions, so it does not need to follow all of the constraints that it has. If it satisfies one of the constraints, then in those cases you could use constraint programming optimization. The next